All right, in chapter 5, we're dealing with rational functions. Those are fractions. And the only thing we know is the bottom cannot equal 0. Because in our library of functions, because we had rational functions, we notice two things that occur. There are certain lines the graphs don't touch. Those are called asymptotes. You have a vertical asymptote. Asymptotes are lines that the graph approaches but doesn't cross. Note a graph can cross a horizontal asymptote but it approaches the asymptote on the other side. Again, now when you take notes, let me pause this. When you take notes, so for example, what this one looks like, let's say this is my horizontal asymptote, and the graph comes in and crosses. As soon as it crosses, it starts approaching that line again from the other side. As you notice over here, they just approach it and it just never touches. But if it does cross someplace, it'll go back to being an asymptote. All right. Let's look at the first one we talk about, the vertical asymptote. The vertical asymptote, I'm going to initial those as VA. Occur where the denominator equals 0. Those are the x values. So we have 1 over x. Since the bottom equals 0, what x is that? And we can't have that. So my vertical asymptote is the line x equals 0. It's a vertical line. And we know that. X equals 0 is also the y-axis. There's a vertical asymptote. All right, that's vertical asymptote. The horizontal asymptote, we haven't talked about that yet. Actually, I think we were stuck doing some examples. We did those. Here we go. Example 3. This is where we left off yesterday. Find the vertical asymptote of the following. F of x equals 2x minus 11, x squared plus 2x minus 8. So whenever you're given polynomials, what's the first thing you should always do? Yeah. To find the vertical asymptote, factor. Factor the entire equation. In other words, top and bottom. For the vertical asymptote, set the denominator factors equal to 0 and solve for x. So we have 2x minus 11 on top. That can't factor any further. And what does the bottom factor out into? What does x squared come from? X times x. Remember, it's the middle variable. What signs go in there? Yes, it's the second sign's a minus, they're opposite, and the bigger number gets what sign? No, the bigger number gets what sign? The bigger number gets the positive. So the bigger number will go here. Now we got to figure out what two numbers multiply together to equal the 8, the last number, that when you, in this case, it's subtract them, you equal the middle number. So it's going to be 4 times 2, 4 minus 2. Since it's 4 and 2, the bigger number has to be positive, so there's our factor. Set both of those equal to 0 and solve. So we get x equals -4 and x equals 2. Again, since both of these, I set them equal to 0, they will make the bottom equal 0. I cannot use those because they'll make the bottom equal 0. So my vertical asymptotes are x equals -4 and 2. So the values I cannot use are the ones I'm looking for. Those are my vertical asymptotes. And this is also going to help us draw a graph later on. X squared minus 4x over x cubed minus x. The first thing you have to do is what? Factor the top and the bottom. So what can we factor out of the top? It's not a, it is a quadratic equation, but only has two terms. Do they have anything in common? On top, do they have anything in common? They both have an x in common. I mean, these aren't trick questions. You look at them, they both have x's in them. So I can take out, you can only take out the smallest number of x's. This one has 2, this one only has 1. So I can only take out 1. If I take out 1x, what do I have left? Remember, I divide both of those. So if I had 2, I took away 1, I only have 1 left, minus the x's cancel, so I have 4. Same thing on the bottom. They both have an x in common, so I can take it out. What I'm left with is that if I took away one x, I have x squared minus 1. I'm not done. I still have a quadratic equation. So on the bottom, I can factor out that. I can factor out the x squared minus 1. Using what rule? FOIL puts things together. You can multiply them. That's what we're trying to do here. Yeah. So what rule says we can factor this? It's called the difference of two squares. Is that a square term? Is this a square term? What is 1 squared? 1. So it is a square term. 1 is everything. It's a million power. It's a 0 power. It's a negative power. It's a universal number. So when you have the difference of two squares, it has to have a minus between it, then it becomes a plus b, a minus b. That's the difference of two squares. Again, those are in your notes you guys never look at. About 8 times. So this one becomes x plus 1, x minus 1. All right, since I'm looking for my vertical asymptotes, I set all of my bottom numbers equal to 0. So they become what? What are my x asymptotes? I mean, my vertical asymptotes. How many of them are there? How many x's do you see down there? You have to have 3 answers. Did you set them all equal to 0? Did you solve them all? Of course not. You're staring at the board still. Nope. You're looking for x. You're setting it equals 0. We said we saw 3 x's on the bottom. There has to be 3 x's on the bottom. There's the degree is 3. So what do we do with each of these? How do we solve them? How do we solve them? All we're looking for is vertical asymptotes. Look at your notes. Vertical asymptotes. Set the denominator factors equal to 0 and solve for x. It's in your notes. It should be in front of you. So what does that mean? What did I just read? All of them said equal to 0. Yes. So what are they? What are my factors? Set that equal to 0. Set that next one equal to 0. And set the next one equal. There's 3 factors. Anywhere you see an x, that's a possible answer. So yes, one of them is x equals 0. The other one is x equals -1, x equals 1. So my vertical asymptotes are -1, +1, and 0. It's not trick questions. It's just there. Anywhere you see an x, solve for set it equals 0. And what we're going to learn later when we start graphing these things, because something can cancel here, it's still a vertical asymptote. I'll still list it, but it now has a name. If I can cancel it, it's now called a hole. If I can cancel that factor with something on the top, it's called a hole, which means unlike all these other vertical asymptotes that are vertical lines like this, on this one at 0, I'll have a hole on my graph. In other words, it's not a vertical asymptote, it's just a hole. But I still can't use that number. There is no answer for it. Whenever a term can cancel with one of the top numerator factors. So whenever anything cancels top and bottom, that becomes a hole, which means your graph, it won't be a vertical line, it's just going to be a hole at that point. What you would do is to find out where that value is. Since this one canceled, I can't use the number 0. That's from a vertical asymptote. So when I cancel this out, I set the rest equal to 0. That's all the x's. Since I cannot use 0, I set all the x's equal to 0. What do I have left? What's my answer? If I set x equals 0 of this.
Yeah.
It helps you write it on a piece of paper instead of having in your head, because this is a math course. You're going to try to work out in your head. Don't do it on paper. Only 2 people are writing. The rest of you are staring at the board like it's going to tell you something. Whenever anything disappears, I take that value, in this case it's 0, whatever's left, I put that value in place of x. What do I have left? Let me help you here. Write this down, put a 0 for x, and work it out. It doesn't help you stare at the board a lot. It's not going to give you the answer. What's that? No. Positive 4. Because we have negative 4 on top. Positive 1 times negative 1 is negative 1. Negative 4 over negative 1 is positive. So at 0, at positive 4, there is the hole. That's where you find the actual hole location. So that's why we factor top and bottom. And the last one for the horizontal ones. I want to know, what are my vertical asymptotes? That's all I want to know right now. So for my vertical asymptotes, these are your vertical asymptotes. This is a hole. Verify that. What are the steps? What's my first thing I got to do? Factor is the top factored? Yes, so the top is already factored. How about the bottom? What can I factor out there? X's. I'm going to take 1x because this only has 1x, which I'm left with what? If I factor out an x, I divide by whatever's left. Right? So it's x squared minus 5. Still not done because this is quadratic. So you're not done until you have your linear factors. So what does this one become? So move it over. Then what do you do? If you square root it, what do you get? Radical 5. That's what's there. So what you have is x equals radical 5 and x equals negative radical 5. That's what this plus or minus says. Set these equal to 0. I move it over. So I have x minus radical 5 equals 0 and x plus radical 5 equals 0. Those would be my factors. So what are my vertical asymptotes? Does anything cancel? No. So what are my vertical asymptotes? The 5 is never going to change signs. It's inside the radical. In other words, these are your zeros. Plus or minus radical 5. So that's how you find your vertical asymptotes. Any questions? Now, that's not the only type of asymptotes we have. We also have horizontal asymptotes. In our earlier examples, what is our horizontal asymptote here? This is our function 1 over x. What is my horizontal asymptote? Horizontal asymptotes. As x goes to positive infinity, your y value goes to where? 0. Or as x goes to negative infinity, your y value goes to also 0. Now, okay, again, I want to know if you understand. So instead of writing it down, because if you write it down, you don't understand what I'm talking about, it's not going to help you any. It's still going to be Greek to you. What does this mean? If you saw this even tonight or tomorrow, this weekend, and you saw that, what does it mean to you? It's approaching a horizontal line. Does it ever touch it? No. Does it always have to be 0? Now, what does this mean? What does that mean? Approach is 0. What does approach mean? Right. So as x gets bigger and bigger and bigger and bigger, what are my y values going close to? It's going close to this one where that y value is y equals 0. Y equals 0 is the x-axis. So what's happening here as my x's bring my graph further away, it's approaching the x-axis. But it doesn't have to always be that. It could be as x goes to infinity, y could approach some value. It doesn't have to be the x-axis all the time. Or as x approaches negative infinity, y approaches also the same value. You notice for horizontal asymptotes, they approach the same value. How is that different than vertical asymptotes?
Uh, vertical is different because you find solutions that cannot go with your.
Okay, that's true in a sense, but what happens? In my vertical asymptote, where does x go to? And then where does y go to? Think of the graph. Think of our graph. Where's our vertical asymptote? It's this one here. What is this line? So that's at x equals 0. Because here we have +1, here we have -1, 2, -2. So the vertical asymptote at x equals 0 is the y-axis. But what's happening? Here's my graph. Here's my vertical asymptote. What is x approaching when something's happening? What's happening at 0? Let me narrow it down for you. Since obviously at 2 has a point, at -2 it has a point, at a billion it has a point on the graph. The only point it doesn't have is where? At 0. Because it doesn't cross it. What happens as x gets closer to 0? What happens to our function? Right. It keeps on going up. It goes to infinity. So in this one, as x approaches 0 from the right, y is going to infinity. What's happening on the other side? As x approaches 0 from the left, what's happening to the graph? Where is it going? So vertical asymptotes, the y values go to positive, negative infinity as x approaches some value. The horizontal asymptote, on the other hand, x goes to positive, negative infinity, and y approaches a value. That's the difference. So, how do we find so how do we find vertical asymptotes? How do we find vertical asymptotes? What about x? What about now put it all together? Give me in one math sentence. What are vertical asymptotes? Because think about how do we find the vertical asymptotes? We factor it out, then we set them equal to 0. So those are the x values that make the bottom equal 0. Those are your vertical asymptotes. Those are lines those lines cannot be crossed. But the horizontal asymptotes can be crossed. But as soon as it's crossed, it has to come back down. So that's how we find the vertical asymptotes. To find horizontal asymptotes, which I'm going to call HAs from now on, to find horizontal asymptotes, you have to look at how the function behaves. So we have a polynomial function that's made up of two polynomials. So that's how we normally write polynomials. And on the bottom, we have another polynomial. I've been writing this all semester. Is everybody familiar with this he's talking about? What are these little ends on the bottom down here? What do they represent? No, the degrees are up here. But there's a reason they're there, because this coefficient is the coefficient of this x value. This coefficient is the coefficient of that x value. That's why they have the same letters. So if I gave you 3x to the 5th plus 2x to the 4th minus x to the 3rd, x squared minus x plus 2. If I gave you that, what is a sub 3? I want you to tell me, don't ask me a question. I want you to tell me what it is. What's a sub 0? That's the constant. 2, very good. What's a sub 1? Negative 1. It's the coefficient of the x with 1 power. What's a sub 2? It's 6 because the power is 2. So what's a sub 3? It's also a negative 1. That's how these things work. We have to know how to associate the coefficients in what part of the equation we're looking at. Now, remember when we talked about the graphs of the basic structure of the graph? What parts of the equation do we look at? What part of the equation do we look at? In the past, whenever we just had polynomials, and I gave you this polynomial, how could you tell me what it looks like? What do you look at? If I ask you to give me the basic idea of this graph, what would you look at? The do what? First degree? That's that one. Of what? What's this term called? The leading term. This is why it helps look at your notes. We talked about this many times. What else is important on this graph? The constant value, because it gives us the y-intercept. So this just tells us y-intercept. That doesn't help us much at all. So the leading term is the most important because it carries the most weight. Likewise here. Whenever you have a polynomial equation, a rational equation, all you have to do is look at the leading terms. Instead of n's, I'm going to make this one m so we can separate them. So all we have to look at is that. This is going to tell us our horizontal asymptote. If any, will the horizontal asymptote be? This will tell us that. Yeah, put it in your own words. More so. Let's narrow it down even further. The leading coefficients aren't really that important just yet. What tells us whether we have one or what it is are the exponents. The degrees of the top and bottom tell us whether we have a horizontal asymptote or not. Three conditions exist. Looking only at the degrees of the leading terms. So we're only looking at the degrees, which are m and n. We're only looking at the degrees of the leading term. N is on top, m is on the bottom. If n is bigger than m, so if the top exponent, the degree is bigger than the bottom, it does not exist. It's actually infinity. Why? Let's look at this. This is our leading terms. Forget the rest of the equation. This is the leading terms. Can we simplify this any? Well, here they both have x's. You're dividing, so obviously something can be done. Well, how can it be simplified? How many x's do you have on top? How many x's on the bottom? What can you do when you divide? You can remove. So I can take away, since there's one here, I can take away one there, so I have two more on top. Remember, when we defined horizontal asymptotes, where does x go? What does x approach to look at horizontal asymptotes? Look at your notes. Don't try to remember it. Yes, no, it's not going to happen. Look at your notes from what we wrote down. As x goes to infinity, what happens to this equation? Well, it's quadratic. The graph looks like this. As x goes to infinity, where does the y value go? Look at this graph. Where's it going? It's going to infinity. It's going to infinity. So if there's more x's on top than the bottom, that means it's going to go to infinity. That means we have more x's on top and there's nothing on the bottom. If the degrees are equal, so let's say we had 2x to the third over 3x to the third. What happens there? What's that? Of course, they both cancel. They're both x to the thirds. So what am I left with? That's my horizontal asymptote. If they're equal, the x's cancel. We're just have the coefficients. Okay, now doesn't mean you don't have to write anything, because I know you want to write stuff, but so the first one, if there's more on top than the bottom, it goes to infinity. If they're equal, they cancel. If there's more on the bottom than the top, what does that one simplify into? Yeah, we lose one of those, so we have x squared. So what happens to this equation as x goes to infinity? Have we seen any type of equation like this before? How about the library of functions? We have x squared on the bottom. What does that graph look like? Again, remember, do the things I'm asking you. What happens when x goes to infinity? What does the y value go to? As x goes to infinity, which is all the way over here, where does y go? Where? Yeah, because it's getting lower and lower and lower. It's approaching zero. So if you have more x's on the bottom, then the number gets smaller. Think of it this way: 1 over 1, 1 over 2, 1 over 10, 1 over 100, 1 over 1,000. The number on the bottom is getting bigger. What happens to the number overall? It gets smaller. So eventually, as I go to infinity, it gets pretty close to zero. So these are the conditions for the horizontal asymptote. Only look at the leading coefficient, or leading term. Here's an example. On the top, we have negative 7 x to the fourth minus 10x squared plus 1, 11 x to the fourth plus x minus 2. What is my horizontal asymptote? What is my horizontal asymptote? So what's the first thing, if I'm asking you for a horizontal asymptote, what's the first thing you should do? The first thing you should do is only look at the leading term. Or get rid of everything else. You don't need it for the horizontal asymptote. So what is this telling us? If you simplify it, what does it become? Yeah, because these cancel out. They're the same value. So the horizontal asymptote is the line y equals negative 7 over 11. That's the horizontal asymptote. So that's the horizontal line. Yeah. I'm not trying to trick you. There's no trick questions here. It's just referencing what we just talked about 5 minutes ago. Another example. Two x plus 3 over x cubed minus 2x squared plus 4. What is my vertical asymptote? It shouldn't take this long. What is it? What are you guys looking at when I ask you the horizontal asymptote? What are you looking at? Look at the leading term. So we have 2x over x cubed. Simplify that. What do you get? 2 over x squared. As x goes to infinity, what happens to this number? Goes to 0. Because we just talked about since there's x on the bottom, it goes to 0. So that's why your horizontal asymptote is 0. All right, let's start putting this stuff together. Example 6 says graph this function. 2x squared plus 1 over x squared. To graph a function, it's a polynomial. What do you think the first things you got to do? We're looking at the whole picture, not just horizontal asymptotes anymore. So we have a lot more to look at now. Which is always the first thing you want to do. Factor numerator and denominator. Because we're not just looking for horizontal and vertical axis, now we're looking for everything else. We have to look for x-intercepts, y-intercepts, and other points. Find the vertical asymptote. Find the horizontal asymptote, if they exist. Find the x-intercepts. Find the y-intercept. This is why if you're using a calculator like Inspire or TI-84, you just type it in there, it'll graph it for you. I want to see all your work. What made you give me that graph? I don't want some dumb box to tell you what the answer is. This will make you even more dumb later on. I want you to tell me what you know. That's what I'm going to grade on. So can we answer any of these questions right now out of this? Which ones?
What?
Okay, what's horizontal asymptote? It's the line y equals 2. Very good. Because the coefficient, the degrees are the same, so it's leading coefficients, 2/1, which is 2. Anything else? Do we know the vertical asymptote? Do we know the vertical asymptotes? Yes, we do. Actually, we should know it. How do you find the vertical asymptote? Do what? And what is the ultimate goal at the bottom? Oh, we can't really factor it. It's just what's there to factor? It's just a monomial. Set equals 0. We want to know where is the bottom equal to 0. Where is the bottom equal to 0? Where is the bottom equal to 0? Is it really that difficult? Can you not set the bottom equal to 0 and solve for x? What do you get? X equals 0. You can't say 0. There's y 0, is x 0, is a degree 0. So x equals 0. That is my vertical asymptote. I took the bottom, set it equal to 0, and solve for x. So x equals 0. What's my y-intercept? How do you find the y-intercept? Think of, do what? Set x equal to 0. If you set x equals 0, what happens? It's what? Okay, so if it's, but it does more than that. Can you, if you put x equals 0, what is my final answer? Work it out on pencil and paper. You have paper in front of you. Tell me the final answer if you set x equal to 0. No. If you set x equals 0, what do you get? It's not that difficult. We only have three numbers in the whole thing. Okay, let me walk you through it then. Find y-intercept. You set x equal to 0. So you have 2 times 0 squared plus 1 over 0 squared. What is 0 squared? 0. What is 2 times 0? What is 0 plus 1? What is 1 over 0? It's undefined. There is no y-intercept. That's all I ask you to do. This is not differential calculus. Just plug them in there and work it out. We knew there wasn't going to be a y-intercept because the vertical asymptote is where x equals 0. So it's not going to cross the y-axis. The line x equals 0 is the y-axis. So x equals 0. That is your vertical asymptote. The line y equals 2. That's your horizontal asymptote. So what happens to the graph? Are there any x-intercepts? How do you find the x-intercepts? You set y equal to 0. The only way a fraction can be equal to 0 is if the top is equal to 0. That's the only way a fraction can equal 0. So all we have to do to find this is take the top and set it equal to 0 to find the x-intercepts. You set y equal to 0 and solve the fraction. All you have to do is take the top. Well, you subtract 2x squared equals negative 1 divided by 2. X squared equals negative 1/2. Square root both sides. We can't do that because we have an imaginary number. You cannot have x squared cannot equal a negative number. It's imaginary. So there is no x-intercept. So because of that, we know the graph can't be down here anywhere. So the graph has to look like this because of our asymptotes. Remember, the vertical asymptote, the graph goes to positive or negative infinity. The horizontal asymptote, it approaches that line. So there is your graph. Okay. What if I gave you this polynomial rational equation? What are my vertical asymptotes and my horizontal asymptote? So what's my vertical asymptote? What, just two? What's that? X equals two. That's my vertical asymptote. How did you find it? Take the bottom, set it equal to 0, and you get X equals 2. Because that's a value I can't use. That's why it becomes my vertical asymptote. Very good. How do I find my horizontal asymptote? Nope. Oh, yeah, go. Okay, keep it going. Keep it going. So we have 2x squared over x, which gives us just 2x. As x goes to infinity, where does that go? Infinity. So there is, because there's more x's on top than the bottom, there is no horizontal asymptote. Except if n is bigger than the bottom, then there is no horizontal asymptote. Except if the top is bigger than the bottom by 1. If the top is bigger than the bottom by 1, then we have an oblique asymptote. Oblique is just a fancy word for slant. The reason we have a slant asymptote because we can do long division to find the equation of the slant line. Now, this goes back to what we did in chapter 1 and chapter 2, or mostly chapter 1. If the top is bigger than the bottom by 1 and you divide them, what are you always going to end up with? X to the 5th over x to the 4th. What do we end up with? Yeah. The 2/3 stays there. X to the 5th, cancel, this leaves 1 left. How about 2 to the 15th over 3x to the 14th? What am I left with? A linear equation. You're left with a linear equation. So if you have one more degree on top than the bottom, then we have to use division and find out what that equation, that linear line is. So we have to take, we have 2x squared minus 3x plus 1, was that minus 1, over x minus 2. So it has no horizontal asymptote. Because it doesn't have it, then we may have an oblique asymptote. You could only have either or. If you have a horizontal, you cannot have an oblique. If you have an oblique, you cannot have a horizontal. So we have to go back and now redo our long division, which is why we learned how to do it. Look at the leading terms. What times x gives me 2x squared? What does it give me? No. What times x will give me 2x squared?
Oh, two, two X.
Very good. I have 1x here. I need one more. So 2x times x is 2x squared. Positive times negative is negative. 2 times 2 is 4x. Change the signs and add. Bring down everything else. Repeat the process. What times x gives me x? X times x is x squared. Nope, can't do that. 1. What kind of 1? You can't just put a 1 here, because then it'll be 2x1. What's missing there? It's a positive 1. There's a positive 1 times x is x. Positive 1 times negative 2 is negative 2. Change the signs. Whatever our remainder is, just get rid of it. You don't need it. This is the only thing we need. That is our oblique asymptote. Is the line y equals 2x plus 1. So let's start putting everything we know together. We have a vertical asymptote at 2. That is our vertical asymptote. Because we set the bottom equal to 0, we got x equals 2. That's our vertical asymptote. Our oblique asymptote is 2x plus 1. How do we graph that? From chapter 1.
You go to 1 right now.
Plot the y-intercept first, and then what?
Up to.
Up to over 1. Very good. Very good. So that's our graph has to fit somewhere in there. It's either going to fit on these outer 2 areas, or it's going to fit in these inner 2 areas. How do we know where they fit? Do we know there's no, we know there's no y-intercept, or is there a y-intercept? The equation is 2x² minus 3x minus 1, x minus 2. Do we have a y-intercept? How do you find the y-intercept? Plug in 0 where? All the x's. In other words, get rid of all the x's. What are you left with? Which is 1/2. So at 1/2, we have a y-intercept. So this is our y-intercept. Get rid of all the x's. Whatever you're left with is your y-intercept. What's my x-intercept? How do you find the x-intercept? Take the top, set it equal to 0. Right. Set the numerator equal to 0. Now with this, since it's quadratic, we can either use complete the square, we can use the quadratic formula, we can try to factor. So what do y'all want to do? Easiest if we use the quadratic formula. So it's negative b plus or minus b squared 4ac over 2a. A, B, C. A is 2, B is -3, C is -1. -3 plus or minus -3 squared, 4 times 2 times -1 over 2 times 2. -3 is just 3, plus or minus 3 squared is 9. Negative times negative is a positive. 4 times 2 is 8 times 1 over 4. 3 plus or minus square root of 17 over 4. Because the square root of 17, square root of 16 is what? So if it was 6, this is bigger, so 3 minus 4 would be negative. So we know we have to have one negative answer, one positive answer. So our graph will look something like this. That's what our graph's going to look like. Again, this is how you graph polynomial irrational functions. Here. Yeah, the quadratic formula, again, we've done that. We've set the whole section dealing with quadratic formula. So doing that really shouldn't be that much of an issue. All right, let's take another graph. So what pieces do you need to know in order to graph a polynomial? Two x plus 3x squared plus 7x minus 6. So if you're going to graph it, what all do you need to know?
What's your verdict?
What do you need first?
Your VA,
Vertical asymptote. What else?
your and your X.
Well, now, because we just talked about obliques, we also, just in case, if the HA doesn't exist, we have to check if there's an oblique asymptote. Remember, because if there's more X's on top than the bottom, there's no horizontal asymptote. But if there's only one more on top than the bottom, then there's an oblique. So that's why you have to check both of those. Then what?
Go find your x-axis.
X-intercept. And then the y-intercept. And then sketch your graph from there. Really, there's only 5 things you have to do. And one of them, or 2 of them, really don't require much work at all. So 40% of this work is already done. Which ones can we do just by looking at it? Which one? The horizontal. What is our horizontal aspect in this one? Right. Because there's more on the bottom than top, our horizontal asymptote is y equals 0. Because there's more x's on the bottom than the top. Because of that, we know there's no oblique asymptote. So that got rid of another 20%. What else can we find just by looking at this? The y-intercept. What is the y-intercept? Which becomes simplify, always simplify. Yeah, it's negative 3 over negative, or 3 over negative 6, which makes it negative 1 over 2. That's where your y-intercept is at negative 1/2. What about the x-intercept? Set the top, which is 2x plus 3, set that equal to 0, which gives us what? X equals negative 3 over 2. Very good. Because it's opposite sign of that one divided by 2. What's our vertical asymptote? That's going to be the important one in this case. What's our vertical asymptote? How do we find the vertical asymptote? If you can't factor, yeah. So let's see if we can factor the bottom. See if we remember how we do that. And set it equal to 0. Since the leading term is no longer 1, it goes in both of these spaces here. What signs go in there? Because the second sign's a minus, one's plus, one's minus, and the bigger one gets what sign? Yeah, so because the first sign's negative, the bigger number goes there. Then we look at the first and last term. 3 times 6 equals 18. What times what equals 18 when we subtract them, we get 7. 9 times 2, 9 minus 2. So 9 goes here, 2 goes there. Then what do we do? Nope.
Oh, you find you have to factor.
Factor it again, yes. Is there anything coming here? Can we factor anything out here? No. Is there anything common here? They both have a 3 in common. So if I divide both of these by 3, I get x minus 3. What do I do with this 3? Remove it. That is our factored form. So from here, we set them both equal to 0, solve for x. What do we get? Negative 2/3 and positive 3. Those are my x-intercepts. So my x-intercepts are at negative 2/3, which is right about there, and positive 3, which is there. Those are my x-intercepts. Oh, no, those are my vertical asymptotes. Because I said the bottom equal to 0. Those are my vertical asymptotes. So these are lines that I cannot cross. These are my vertical asymptotes. The horizontal asymptote is the x-axis. The x-intercept was at negative 3/2, which is at negative 1 1/2. Crikey, hold it. I put the wrong signs. It should have been plus. So the bigger sign gets the plus. So the answer crosses that. So this becomes x plus 3, x minus. So it's at negative 3 we cross. So we have at negative 3 we cross. Or we have a vertical asymptote. And a positive 2/3. Those are my vertical asymptotes. Horizontal asymptotes to that one. So my x-intercept is still negative 3/2, which is at negative 1/2. That's my x-intercept. The y-intercept is at negative 1/2. Now, in the middle, since you have multiple parts here, we have 2 vertical asymptotes. Since it has an x-intercept and a y-intercept, because if you have vertical asymptotes like this, the inside, it could be a parabola, or it could be a line that crosses both x and y axis. So in this one, it crosses the x-axis, it crosses the y-axis, so the middle part of the graph has to look like that, since there aren't any more x-intercepts or y-intercepts. Which also means, since there are no x-intercepts on the outside here, the graph's either going to be above it or below it, above it or below the x-axis. We don't know where, so we plug in a number and plug it in the equation. So we have 2x plus 3 3x² plus 7x minus 6. If we plug in a positive 2 in there, is the top going to be positive or negative? Positive. Bottom is going to be positive or negative. 2 squared is 4. 4 times 3 is 12. 12 plus 14, so it's going to be positive. So this one's going to be positive. So it has to be above the x-axis at 2. And at -4, since this -3 is my vertical asymptote, what's happening outside of that? At -4, -2 times -4 is -8. So the top's going to be negative. And the bottom is -4 squared is 16. That's 48. It's going to be positive. So the answer is going to be negative. So this one has to be down here. I'm just sketching the graph. If I want to know exact points, then I work this out with these points and then put the exact value there. But I'm just sketching the graph right now. What do y'all think? It's the same 5 things you got to find. Let's look at another one. X² minus 1, x² plus x minus 6. Oh. That's no, one more. So what are the 5 things we got to look for? Vertical asymptote. All right. Since both our top and bottom are quadratic equations, they're polynomials, what do we do with them? Factor them. Always factor. Bottom line factor. Answer is always factor. X² minus 1 factors that into what? It's the difference of 2 squares. And what does the bottom factor out into? X and X, opposite signs. What times what is 6? When you subtract them, you get 1. Two numbers that multiply equal 6. When you subtract them, you get 1. 2 and 3. That's the only thing it can be. And the bigger number gets the plus. So it's 3 and 2. All right. Let's start with the easy one. What's the easiest one of all of them? Okay, horizontal asymptote. What's our horizontal asymptote? One. Because they're both the same degrees, if you cancel them, it becomes 1. And their coefficients are 1, 1 over 1. So that means we have no oblique asymptote. We've just done 40% of it. What's the next easy one? Looking for the y-intercept. The y-intercept is the next easiest one. Why? Only look at the constants, which is 1/6. Because all the x's, erase all the x's, you have -1/6 becomes 1/6. And the next easy one from here would be the x-intercepts. How do you find the x-intercepts? Well, set the top equal to 0 or factor it out. So it's going to be x equals 1 and -1. Those are the zeros on top. That's the x-intercepts. And the vertical asymptote is what? All right, so the bottom equals 0. That is the basis. Once you have these, the graph pretty much draws itself. So we have a vertical asymptote at -3. Vertical asymptote at -3. And at +2. Horizontal asymptote at 1. X-intercepts at 1 and -1. And y-intercept at 1/6. So in the middle, whoops, -1's here. I'm sorry. That's -1. That's -2. So at -1 and 1 and at 1/6. So the middle part here has to look like this. To satisfy those intercepts. Are there any other x-intercepts? No. Since there's no x-intercepts, the graph has to be up here. All right, let's do one more. Then we'll finish out the chapter. We have the vertical asymptote, the horizontal asymptote, the oblique asymptote, the x-intercepts, and the y-intercept. And our graph. So what can you tell me so far? Yep, it's the x-axis. Why? Because there's more x's on the bottom. So that's my horizontal asymptote. What else do we know? Because we have a horizontal, we can't have an oblique. The y-intercept is +1 because -2 over -2 is +1. What else? X-intercept is 2. How'd you get that? Yeah, set the top equal to 0, so you get 2. It's very good. So the x-intercept is at 2. Actually, we'll hold off, put a pin on that one right now, because we haven't found the vertical asymptotes yet. What are my vertical asymptotes? What times what is 2 when you subtract them, you get 1? 2 and 1. So the negative gets the 2. So if we look at what we have now, we have that equation. A problem just occurred. Can anything cancel? X minus 2 cancels. So at x minus 2 equals 0, we have a hole. So when x minus 2 equals 0, so that happens at x equals 2. So it's no longer an intercept. It's now going to be a hole. So, and then because of this, our equation now looks like this. Because the x minus 2's cancel, this is all we have left. We have 1 over x plus 1. That's what happens if anything cancels up in the bottom, which is why we factor it out first before we do anything. So when x equals 2, what does this become? 1 over 3. So at 1/3, we have a hole. The graph now crosses through that one. What are my vertical asymptotes? Or asymptote now, since this one's gone. It's at -1. So at -1, we have a vertical asymptote. Because we have these, our graph looks like this. Because our new graph of our function is 1 over x plus 1, which is a shift to the left 1, and it's the 1 over x function. And that's all. That's how you sketch them. Again, now if you wanted a perfect picture, then you'd plot some real points and connect the dots. But you know what the shape of it looks like now. That's the end of that section. The last section of chapter 4 is actually pretty, compared to all of this, it's simple. It's the stuff we've been doing already.